from Reliance, heading the process safety, and it's my privilege here to be chairing the session for all the elite speakers here coming from various technically deep backgrounds. And this session is very important and close to heart for all of us in the industry, various facets of energy industry, because HSE risk management is basically critical to sustenance of the business as well, as much as it is important for protecting lives and the environment. So recognizing that, so I welcome the speakers to provide their insights. And before we start off with the speakers, a couple of points. We have 15 minutes per speaker, and I would request us to adhere to the timing. And for the audience, we will take the questionnaire towards the last of all the presentations so that we can take them all in sequence. And I now welcome the first speaker, Mr. Aniruddha Kulkarni, who is a manager in R&D, BPCL. Welcome, Aniruddha.
Good morning, everyone. So I'm going to present a topic on the world's most energy efficient natural gas domestic cooking stove. So this is the outline of my presentation. I will start with the present status of natural gas. Then I will just give the brief about our LPG burner, which is the high energy efficient. Then what is the need for the dedicated PNG stove? What is the development process? Then testing as per BIS, prototype preparation, and then benefits. So what is the present status? Now we have a talk that India is expected to become a gas-based economy, and we are slowly shifting from the cooking fuel like from LPG to PNG, that is pipe natural gas. Okay, but when we are shifting from LPG to PNG, nobody has thought that can we have a different kind of burner to use the PNG, because in number of terms of volumes, we are the highest one in the world. At present, in India, we have around 30 crore LPG customers, and it is expected that out of 30 crores, 12 crores will be shifted to around 12 crores by 2030. So almost, I will say 40% we are going to shift from LPG to PNG. So, and we are, if we go to the market, what they will do, they will just give you the old LPG stove with some modification to use for the PNG. So at present, there is no dedicated PNG stove available in the market to use effectively the PNG. So in a good cause, we are shifting from LPG to PNG. It is a clean fuel, but are we utilizing the energy efficiently? This is the question on the, because we have to utilize the energy very cautiously since it is a precious. So like before 2 years, related to the similar line on the LPG front, we have launched Bharat High Star LPG stove, which is world's most energy efficient LPG stove with 74% plus thermal efficiency. And our claim is that whatever the burners are available in the market, it will save 1 cylinder per year as compared to 68%. And it has huge potential because we are importing huge amount of LPG. So in the similar line, if I talk about the PNG case, so I will just give the brief background how the stove is working. So if you see on the left hand side, I have put just to get the familiar with the stove construction. If you talk about the cooking stove, it consists of nozzle, then the mixing tube where air fuel mixing takes place, burner top from where the ignition starts, the cover plate which is the annular portion just behind the burner top, and the pan support where you keep the vessel, and all the combination we call it cooking stove. And if you see the right hand side, we have the working principle. So how it happens, from the small nozzle, fuel is injected at very high velocity and low pressure. So inside the mixing tube, the pressure low pressure zone is created, and because of low pressure zone is created inside the mixing tube, the primary air gets into it, and the air fuel mixing takes place. And after that, it will come out from the burner top, and where you can ignite the fuel and you can utilize the energy. So at present, what is happening, whatever the burners are available in the market for the LPG case, they are having the efficiency 68% or 74%. And if I talk about the old stove, if you are the old user of LPG and you have the old burner of around like 5 to 10 years old, the efficiency get reduced around 15 to 20%. And apart from that, if you convert the same LPG stove by just changing the nozzle, so when you have seen that when you are shifting from LPG to PNG, what will say, the one guy will come from the maybe IGL or from the gas company. He will just put one rimming into the nozzle. So what he will do, if I compare the volumetric calorific value of LPG or PNG, it's almost 1/3 of LPG. So we need to put more fuel into the burner. So he will just increase the diameter of LPG nozzle and he will give it for the use of PNG. So what will happen? The efficiency will again go reduced to the 40%. So, and if I talk about the number of customers, at present we have 1.2 crore customers, and by 2030 we will have 12 crore customers. So we have to save the energy and we have to use it effectively. So keeping that in mind, we thought that we should have a dedicated PNG store, and we have developed it. So how it is happening? So initially, I'm from the R&D background, so I will explain the product development process. So we use the modeling, simulation, and validation process for the product development process. I'm going to explain in detail of the each in the coming slides. So first, what we do the exact diameter CAD model, and for that we use 3D scanning techniques and then the basic measurements, and we prepare the CAD model. Then we use the CFD simulation software and we will have the domain identification, and then we do the cold flow analysis and combustion analysis, and then we prepare the prototype of each the burner. And because whatever we are getting the results in the simulation software, we have to validate it. It's not like if you are getting the very good efficiency in the simulation and what is even actually may be different. So we have to repeat the process and we have to do a lot of permutation combination to achieve the final result. So if I talk about the stove part design, these are the main three parts what we have worked for. The first one is the burner top. If you see the burner top, it consists of very small portion of the burner, but it consists of number of holes. So we have checked with how the holes are at various angle. So we worked on the inner port inclination angle, outer port inclination angle, diameter of the holes, then how they are placed, and number of holes. And even if you see, there are 2 rows outside, 1 row inside on the burner. There can be multiple combination of 3 row outside. So because it will create a better flame structure. So by keeping in mind that it should have a better flame structure and it will give the accurate energy to the cooking purpose, and keeping all the fuel parameters in mind, we have developed the burner top. If I come to the mixing tube, my main focus is to have the better air fuel mixing. So if you see, if you take your burner and check the below surface, it is having the state section. So we thought that can we modify that state section to maybe converge divergent section, or maybe some having the angle to it, or maybe we can put venturi inside the mixing tube, so it will have a better air fuel mixing. So better air fuel mixing will give much more better combustion efficiency in the process. So keeping that in mind, we have developed the mixing tube. And coming to the pan support, if you see, we have only the simple pan support with some 4 legs. So pan support plays a major role in the complete process, because pan support leg height will determine the loading height. So what exactly loading height is? The distance between the burner top and the vessel bottom. So that plays a very important role to get the high efficiency from the burner. So this is how we have designed the pan support. So almost I will say the burner top from the new design of the burner top, we are able to get very good efficiency, then mixing tube and the pan support. So combination of all 3 effect, we have developed the PNG burner with a 72% plus thermal efficiency. So when we did some literature search and market search also, what we got to know that Indian Institute of Petroleum, in 2019 they have developed the PNG stove, but efficiency was 55% only. So we thought that 55% is always anyway less, and if you convert the present LPG stove to PNG also, it will give some that kind of efficiency range. So this is the first one of the 72% plus thermal efficiency. It is almost 10 to 15% more efficient than the burner available in the market. We have filed patent at India at present. And in terms of PNG consumption saving, 25 to 30%. So if you use our PNG burner for the each household, you can about to save 25 to 30% the PNG bills. Now the customer benefit. So I will take one case one first. New LPG stove. The thermal efficiency is 68% for the LPG. After modification to PNG, the thermal efficiency will reduce to 50%. And with Bharat High Star natural gas stove, the efficiency savings will be in around like 25 to 30%. And like for the most of the customers who are using the LPG from the long term, and nobody changed the burner for almost like 5 to 10 years or more than 10, 15 years, unless it is completely broken. So efficiency get reduced to 55%. And if you modify it for the PNG, it will go, efficiency will reduce to 35%. And so if I talk about the savings in terms of the natural gas, the new burner, it will be around 45 to 50%. So we should think of getting the ready PNG stove, so you can give better benefits to customer. Now, if I talk about the benefit to the nation, because since similar to LPG, we are importing huge amount of natural gas from the outside, and we are spending a lot of foreign exchange to import this PNG. So what we thought कि the number of customers in India is volume is so high. So if I say that 1.2 crore customers, if we can save 1 kg of PNG at each household, we can straight away save 1.2 crore kg of PNG every year. And this will be multiplied because we are going to expecting more number of customers. So we are our PNG stove is giving benefit to customer as well, then giving benefit to nation as well, and it is also giving a benefit to the environment, because around 1 kg of PNG stove produces 2.75 kg of carbon dioxide. And since our volume is so high, we can definitely reduce that much carbon dioxide emissions every year in the country. So with our BPCL main tagline, main tagline was energizing lives. So I will put that one more line word before that. So BPCL, beyond fuel, energizing lives, leading the charge towards a greener and more sustainable tomorrow. And we always tell that we are working towards the net zero of the company. So we should actually start the journey of net zero from home, because the every small change will lead to the greater change in the country. So with that, keeping my presentation short, I am concluding my presentation. Thank you.
Not Aniruddha, not only that you have saved potentially a lot of gas, also the time. Thanks a lot for the insightful one. This connects all of us in our domestic front, and this has been one of our intriguing question in my mind also all the while. All the retrofits that we are doing for the gas stove through unprofessional technicians and all, I think this stove will give a high star performance.
Yeah.
Thank you.
Thank you.
So the next presenter, please. So we have Mr. Siva Kesava Raju, who is Senior Manager Analytical R&D HPCL, who is going to talk on the HP gelators and SOS. Welcome.
Good morning, madam. Thank you, IEW, for giving me the opportunity to present this work. So I am from HPCL Green R&D Center. So compared to other PSU R&D Center, this is literally a little young. So this was inaugurated in 2016 by then Petroleum Minister. So in like we have during short span of time, we have almost filed 500 patents and granted 200 patents. So I belong to analytical and chemical synthesis. Apart from giving analytical support to various other labs, we also involved in chemical development. So we develop different chemicals and additives. Recently, we working on like new water research lab. So coming back to this talk, so this is on HP gelators and HP sorbents for oil spills. It is a potential solution for oil spillage remediation recovery. Yeah. So if you see, like recently, oil spills is becoming a more and more difficult environmental challenge, especially after 2010 Gulf of Mexico deep water horizon. So several oil is actually spilled. Almost BP has to spend almost $65 billion, and for only environmental production they have to spend another $20 billion. So this is oil spills is like problem not only for environment and fauna and other things. Also, it consumes a lot of money for whoever the spill happened. So like this one, so this oil spills, it is actually problematic for the environment. Also, any company it gives it, it has to spend a lot of money on recovery. So what are the available methods? So so normal methods people use booms and skimmers. So but the problem is it is a non-selective removal, and people do in situ burning. So in situ burning it requires high energy consumption, and spraying chemicals. So it is a pollution, and you are adding more new chemicals to the like pollution range. And bioremediation, though it is good, but it is very time consuming. So what are the different alternatives? So we have to select some highly selective necessary development. What are the necessary developments? So the material should be highly selective, and it should have good absorption capacity, and normally it should be bio friendly, and it should not cause any problem to the environment. And whatever we prepare, it has to be done easily prepared, and finally we have to scale them. So keeping this in mind, so in HPCL R&D Center, we develop a different type of materials. One material is consuming material are gelators, which I am going to talk more in next few slides. Another one is sponge absorbents and powder sorbents and hydrophobic seeds. So first part, what HP gelators? Gelators means it will gel with hydrocarbon materials. So in this, we develop two types of molecular gelators. First one is a dipeptide based. So dipeptide, the advantage of dipeptide based gelators is by modifying the structure, you can make it either oil selective or water selective. Second one is sugar based gelators, where we taken different sugars like mannitol, sorbitol, xylitol. We made hydrophobic, and that is used for the oil selective removal. So this is how it will absorb the oil. So first I taken different petroleum cuts like styrene, naphtha, diesel, and also we want to check with vegetable oils. So you can see how it forms like a jelly type material, and we taken different crude oils of different API, from one from low API and one from high API. So it is how it will form. So I like this is one example. You can see crude oil in water. So oil normally it will floats in water. So once you form a gelator, it will form like a jelly type of material, and then that jelly type of material can be scooped out. So what we have observed is like lighter fractions like naphtha, and naphtha is having a very high selectivity, and over the like density, once the density increases, the selectivity slightly reduces. And even crude oil also, crude oil with high APA has a good selectivity compared to low APA, but still we can observe up to 45 to 75 times more. And vegetable oil also, we have seen that almost 60 to 200 times more absorption capacity. So gelators are very good materials, novel materials, but application in like broader range is difficult. So what we have taken is the next material we take consider is the sponges. So this is how like normal sponge for color differentiation. I used actually potassium KMNO for solution. So whatever is a pink solution you are seeing, it is like a water mixed in KMNO for solution. So normal sponge, that water will go inside. Modified sponge, you can see that water droplet is staying, so it is the sponge material we is made it hydrophobic. Here also, like we taken different fractions, and we analyzed, and we found like this is the absorption capacity what we can see here. So sponges also, we different sponges we have taken. So what normal mopping pads also we taken, that we modified as a hydrophobic. So here like kerosene, whatever is Curocut is there, that is in blue color. So the blue color, and we have taken water. So he can see here that all the blue color is absorbed. Blue colored dye having kerosene is absorbed to the like sponges. So then we can just squeeze it, and you can get back the material. So these novel HP sponges are developed, which are easy to synthesize, and this actually we done initially in the lab scale. After that, what we have done is we want to mimic, we want to do in the larger scale. So this is actually 1 KL tank we have taken. We artificially added crude oil to that one. That crude oil again, we are able to recover almost 98 to 99% of crude oil with this method. So third material we have taken is a bioabsorbance. So for this purpose, one cheaply available material like sawdust we have taken. This sawdust we modified with our hydrophobic method, so that sawdust, once it is modified, it become very hydrophobic. You can see here water droplet how it is. You can see from it is water droplet how it is actually initially saw without modification water is gone inside. Here water droplet, even water droplet also not gone inside. This also advantage like it can be filtered and you can take out the oil with this method. So this is one example that we added crude oil to the water. So the crude oil, all the materials, we are able to, all the crude oil is collected to the biomaterial. After that, we can filter it. So fourth type of material is like HPSOS seeds. This is SOS means sorbents for oil spill. You can, for the color difference, we have put like a different colored material we had it. So whatever you're seeing is the water droplets. This is which is floating onto the seeds. So for this practical application, we want to check in refinery. So refinery is the whatever we want to experiment. The main experimental place is refinery. So these seeds were actually in combination we have put, and we this is actually one ETP like outlet we collected. So this all the oil it is gone to the gone and collected onto the HPSOS seeds. After that, we are able to extract the oil. So, to summary, we have different type of materials we developed, mainly HP gelators, which is gelatin materials, which can which can has more of absorption capacity, and HP biochar. So this is biochar modified materials which we can use as a very simple materials, and HP sponges. You want to use in a higher concentration sponges material as a very efficient materials, and then HPSOS is sorbents for oil spills. These are seeds which we can use for like a higher oil uptake. So this work we had already 6 Indian patents and 4 US patents, and we published in 3 international high impact photo journals. So this HPSO seeds we distributed to various locations for minimal oil spill, and so this is my biodata. Thank you.
Thanks a lot, Rajuji, for covering a very, very important and a sensitive matter. I hope this will prove a very good solution for all of our coast protection and water pollution control. Thank you. So now we invite the third speaker for the day, Saurabh Mishra ji, Assistant Professor, Center for Advanced Studies, Lucknow. Welcome.
Respected chair and respected speakers and dear audience. So I'm here for the presentation on the research work titled Preserving Ocean Ecosystem, Innovative 3D Porous Sponge for Offshore Oil Spill Cleanup. So, and my co-author Gitanjali Chauhan is also present in audience. So these are the outlines of my presentation. So introduction is covered by our last speaker, sir. So, so this is a major, very major concern of the marine environment. Like while we are turning our faces toward the renewable resources of, energy, but whatever it is, but we are also dependent on, still dependent on the fossil fuels. So, and we generally know that we like waterways are the like mostly used for the the transportation of these fossil fuels to the one country to the another country. So what happens is due to the breakdown and failure of the equipments and due to the people making mistakes, there is accidental release of this like crude oil to the over the marine water. So what happens is the species residing there, they will be like who polluted my home and who did this. So this is us because we needed that crude oil and its derivative for our use. So it's our responsibility to clean up that marine ecosystem. So these are the major oil spills around the world, and you can that have been like caused the devastation to the species and marine ecosystem. So you can see like how destruction has been made by this oil spill. So while during the literature review that is present available on the scientific platform, uh, like we found that a lot of researchers and scientists have like developing uh, some effective techniques and some effective processes to clean that spilled oil over the marine environment. Some researchers have developed some sponges and all. So we have also attempted to develop a 3D sponge structure that can recover the crude oil that is spilled on the water surface. So on the basis of that literature review, these are the objectives of my study. That is to maximize the recovery of spilled oil, and to develop the effective and efficient 3D sponge structure, and to investigate its performance, how it is recovering, how it is trapping the crude oil over the marine ecosystem, and to check the performance, yeah, to characterize that sponge structure for the other insights. So there are three types of oils that we use for investigating the performance, like crude oil, diesel, and mustard oil. So this is the like workflow we have adopted to fabricate the 3D sponge structure in our laboratory, and we have used the sugar template method for for fabricating the 3D sponge. So we actually before 3 or 4 years, I was walking to my college, and I just encountered some hairs, lying down in the soil. So I thought like this is a totally waste, and they are having mostly the carbon inside it. So the thought came, and I thought like, okay, if we can utilize these things to prepare a sponge, or to utilize in anything, so it will be very very good. So idea came from that. I utilized that human hair, but the thing is, there is something called size. It matters, because the function which an elephant can perform, an ant can. So I thought like, if you can reduce the size, and if I can offer a large surface area, it will be having a large surface area, so that it can absorb the more and more oil from that marine environment. So I also utilize that polydimethyl siloxane with the human hairs also. So for that, we heat treated those human hairs at the temperature ranging from 200 degrees centigrade to the 900 degrees centigrade, and we found these. You can see in the figure two, these extract from the heat treatment. So this was the method we adopted for the fabrication process. Uh, so you can see in the figure 3 that these are the fabricated sponges uh, we have uh, we have in the laboratory, and after that we have gone for the characterization and to check its performances. So this is the workflow of investigating the trapping capacity of that fabricated 3D sponge structure. And you can see the formula, how that trapping capacity was calculated. So these are the result of my experiment or the investigation. So in the figure 7, we can observe like there is an increment in the the trapping capacity of the sponge structure. As we utilized the human hair heat treated at the temperature, as the temperature is increasing, we are observing an increment into the trapping capacity. That means, like, with the temperature, the surface area was increasing because of the size, and uh, that size, that surface area resulted in the higher trapping capacity. And this experiment was repeated 5 times, and the average of experiments are shown here. And you can see the trapped oil into that sponge structure. So it is looking very good. So uh, now recyclability, reusability is a major is also a major concern with this. So like uh, we have conducted an experiment for 20 contact cycle. That means 20 times we utilized a single sponge structure for recovering, for trapping that crude oil. And here is the result. We can observe an increment into the trapping capacity. That may be due to the destruction of that pore space, and opening of that pore space so that it can trap the more and more oil. So again, wettability is a major characteristics of that sponge, because it's very important to whether it is hydrophobic or hydrophilic. Means we don't want to recover the water. We want to trap that crude oil from that marine environment. So this fabricated sponge structure have shown the super hydrophobic nature and super oleophilic nature, because the contact angle was greater than 150 degree. So we have also gone for the morphological study, and in the figure 15 you can see the pore opening. This is the pore which will be trapping that crude oil inside it, and this is the pore structure in the figure 16 and 17 you can see. And the human hairs are on the surface of that pore structure, that may offer a adsorption phenomena into that sponge. So these are the pore opening, and it may vary from 1 micrometer to the 40 micrometer. So this is the Brenner Emmett Taylor analysis, which gives us the surface area analysis, like how much surface area that a human hair, heat treated human hair, can offer. So with the increment in the temperature, you can see from the table that the BET surface area increasing. That means we are having a large surface area for trapping the crude oil. So these results are like validating our study that yes, this can happen. So okay, now I'm concluding my presentation that we have fabricated the sponge structure that was showing the effective oil spill cleanup, and we utilize the human hair. That means inclusion of human hair can enhance the trapping capacity of the sponge structure. And this is totally eco-friendly, because we have not used like any toxic chemicals and all. We have utilized the waste material to fabricate the sponge structure. So this is totally eco-friendly. So this is a short video that we have taken into the laboratory. So the trapping is you can see the trapping of diesel oil into the pores of that sponge, and it was performed for 2 minutes. And in the last of video, you will see there will be no diesel droplets into the water. So it is absorbing and trapping that crude oil into its pore spaces. Some capillary actions may be taking place. So this is a phenomena. Now you can observe that the diesel oil have been trapped by this pore space, by the pore structure of sponge structure. So these are the references we have taken. So I acknowledge my director and my colleagues and my supervisor, Dr. Keka Oja, for motivating me. And I also acknowledge the faculty members of my center for the support. So thank you so much. Thank you so much for your patience. Thank you, ma'am.
Thanks a lot for an interesting one. So you proved that hair fall can also be a utility,
Yes.
but for a larger good.
Yes, sir.
Thanks a lot for the innovative
Thank you.
idea.
Thank you. Thank you.
We now welcome the fourth and the last speaker of the session, but not the least, Mr. Vishvanath Reddy Guram, Senior Manager IOC, who is speaking to us on mitigating the H2S risk, which is one of the largest problem statement in the energy industry.
Thank you, ma'am. Thank you for the introduction. Good afternoon, everyone. So the topic that we are going to discuss here is regarding an upstream well operation, wherein we faced a very high H2S percentage during the well test operations. The methodology deployed for management of H2S as well as the design practices that were implemented for the operation will be presented in this case study. To set the things in perspective, you can see the different limits of H2S which could be hazardous to the health. 100 ppm of H2S is immediately dangerous to life or health as per the classifications by OSHA. On the left side of the screen, you will see the actual measurement of H2S that was encountered during the operations. The dragger tube measurement shows H2S ranging from 16% to 32%. 32% of H2S is 3,20,000 ppm. So the level of exposure and the hazard that it can cause is extremely high. So a little bit of background on the operation, where the operation took place and who were the operators. So in the year 2019, Indian Oil with its partner BPRL, Bharat Petrol Resources Limited, ventured into an upstream journey in Abu Dhabi, UAE, wherein we are currently drilling a number of wells to explore crude oil and gas. The case study focuses on well X, let's term it well X, wherein the well was drilled up to a depth of 11,000 feet. And the H2S percentage encountered during the operation was ranging from 16% to 32%. So any upstream operations will have multiple uncertainties because you are venturing into a field wherein you are diving 3,000 to 5,000 meters below the Earth's surface. So this uncertainties could range from surface to surface and other miscellaneous operational uncertainties. In terms of subsurface uncertainty, just let me focus on the case that we have here. The offset well data showed that the H2S percentage will vary up to 5%. But the actual case presented H2S percentage of more than 30%. That's a fluid composition subsurface uncertainty. Similarly, on the basis of surface uncertainty, you will have H2S handling capacity will vary from 5% to 32% a large. The HSE management issues, how will you tackle the fluid evacuation, those sort of uncertainties are addressed to the surface uncertainty problems. To start the operation with, there were two different perspectives from HSEIA preparedness point of view. The different studies in terms of hazard, HAZOP, simultaneous operations, safety, subsurface safety plan, and then dispersion modeling, etc., are one set of activities that was performed for actually conducting the well test operation. I am talking about the point of time wherein the operation has still not started. Now, the milestones wherein this operations was to start with involved in terms of HSE preparedness on how you are actually going to design the subsurface tools and equipments that you are going to lower into the well, how you are going to manage the H2S which is going to be present at the surface, and all the data acquisition. Drilling a well, the point of view of drilling a well is actually the acquisition of data. So how you are going to acquire the data, that's another important perspective. Now, the scale of operation could be envisaged from the point of view that the operation that we are talking about involved more than 100,000 man hours. In terms of, it was spread around 120 days of field operations involving more than 100,000 man hours. We had more than 2,000 observation cards issued from different service partners of ours, and more than 200 safety meetings were conducted just for the conduct of operation itself. We had round-the-clock 24-hour HSE officer deputed at the field site for monitoring the operation, as well as we deputed a third-party surveyor just to identify any gaps before start of the operations. Prior to start of the operation, there was an emergency response protocol which was initiated at the well site, wherein we designated each and every service provider on how they will respond in case of any S2S alarm, if the S2S alarm goes on. So the responsibility was distributed among different service partners. All the rescue team as well as the field site personals, they were provided with multi-gas detectors as well as the breathing apparatus on 24-hour basis. They had to move across the well site with those operational setups with them. So now comes the stage of operation. Like I told in the beginning, before start of the operation, we conducted dispersion analysis and HAZOP and hazard studies. So those studies were limited to 5% of S2S. That is what we were planning for based on the offsite data that we had in the field. When we encountered an S2S ranging from 32% to 35%, the study goes haywire. It doesn't mean anything. I mean, the study doesn't, the findings of the study you cannot hold true for the operation perspective. No, so what we did was we shut down the operations. As soon as we started getting S2S percentage beyond the limit that was simulated, we shut down the operations instantly. We went back to the desk. We planned on what the new findings are, what is the new S2S limits that we have, and how to actually plan an emergency planning zone and awareness zone in terms of the new S2S percentage. So the peculiar case why this well is very important in a sense is, you can see there's on the red circle that you have, that's an emergency planning zone. Just beside the red circle, there's an international highway which is moving from UAE to Saudi Arabia. This international highway, you cannot shut down an international highway in case of any S2S dispersion or leakage. So that's the first regulator problem that we faced. You cannot shut down the international highway. Now, how to move ahead? To move ahead, you have to trim down the operational parameters. The operational parameters were trimmed down in a manner that the emergency planning zone does not touch the international highway. Emergency awareness zone, you can have emergency awareness zone across the highway, but then you have to plan in a manner that the operational, as soon as the operational parameters goes beyond the limit, you have to again shut down the operations. The first perspective was in terms of regulatory challenges. The second perspective on how your equipment or the tools that you are actually utilizing will meet the challenges. So, like I said in the beginning, though the offset well data was for 5% of S2S, but it was an exploratory well with uncertainties. We planned ahead with 27% of S2S. That is what the planning was for. However, the S2S percentage was still beyond 27%. So we went back to the service partners. We sat down together, in the 24-hour shutdown period that I'm talking about, we had multiple meetings with the different service providers, wherein we discussed on what are the challenges these tools will face if the S2S percentage is beyond the limit. So we recalibrated the barriers that were actually present inside the well. We went back to the OEMs and discussed on if the barriers that are actually present in the well will be able to meet the 32% S2S or not. So thankfully, with all the service ratings that we have up to 27%, the material was equipped to handle up to 36% of S2S, and it helped us in moving ahead with the operations. Now, the third perspective, the tool is okay. The HSCIA regulation was okay. The third perspective was the crew readiness. During that 24-hour shutdown period, we prepared the crew to handle the S2S, high S2S percentage that we were encountering at the field. We stopped the ingress at well site. Only 6 persons were allowed to move in the zone of 200 meters from the well mouth. Those 6 persons were from the service partner and from the operator side, that is from our side. And apart from those 6 persons, no one else was actually allowed to move across the well site. So with all these preparations in hand, still the challenge was not finished up. The decision tree and the flowchart that you see in front of your screen was actually how the well test operation moved ahead. So, like I said in the beginning, if the H2S percentage was beyond a certain limit, you have to again shut down the operation, then again recalculate the EPZ and EAZ limits, and then if the EPZ and EAZ limits are within the permissible code of practices of ADNOC is the regulator there, then you can move ahead with the operations. So this flow chart will take you on how actually the operations were moving. I will just take 30 seconds across this flow chart, and I will go across the yes zone rather than the no zone. No zone is actually cancelling the operation. So just take you through the yes zone. If authority confirms the readiness to close the public road in case of hydrocarbon leak, if they say no, then you have to have H2S percentage below the limit that you are planning for. Otherwise, you have to cancel the testing operation. If the readiness is there, then you collect the samples of the well test operations and carry ahead with the operations. Otherwise, if the readiness is not there, then you have to recalibrate the operational parameters in a manner that the EPZ and EAZ is within the allowable limits. Now, like I was discussing this, this is the well test process flow diagram. The main point that we were discussing is the international highway that was moving across the well site. You can see a cargo truck, transport truck on the left-hand bottommost picture. That's just at 600 meters from the well site mouth. And this is the international highway that I was actually talking about. Now, there were many engineering aspects that were actually adhered to while designing these operations. I will just discuss the two main primary aspects that we implemented with the help of our service partners. The first important barrier in any well flow operation is actually subsurface barrier, a hydraulic packer, which is actually deployed inside the well. The hydraulic packers that we deployed inside the well were treated to bear H2S percentage of more than 36% and were actually set without any weight. So the packers, in perspective, to put the things in perspective, the packers that you lower inside the well are set through a weight. And we deployed the packers which does not require any weight to be set. And this helped us in removing the part of the string which may actually undergo sulfide stress cracking when high H2S is present inside the environment. The second important aspect that we deployed at the well site was auto ignition devices. The topmost picture you can see is of the auto ignition device. This auto ignition device helps you to ignite H2S if it is present at the well site. If some sort of leakage has occurred, then you can remotely auto ignite the H2S before the dispersion takes place. And this is a mandatory requirement in terms of if the H2S percentage is beyond certain limit. The outcome of the testing operation, you can see the corrosion that happened from the tools that we actually pulled out from the well, and that itself shows on the impact of H2S on the downhole tools. So this is just the well operation summary, wherein we successfully got oil at surface, gas at surface, and thankfully the BSNW was 0%, and this helped us a lot because you all might be aware that if water is present in a corrosive environment, it leads to altogether a different sort of corrosion. So this helped us a lot that BSNW was 0% throughout the testing operations. Okay, so once the operation was finished, then we went ahead with the successful suspension of the well. The well has been suspended in the manner that we have put approximately 800 feet of cement plugs across the H2S zones that were encountered in the well. We had a surface plug also, and we have capped the well with inhibited brine. We have treated the well fluid with high percentage of H2S scavengers so as to prevent any sort of corrosive activity with the well. The well is currently in suspension with zero annulus pressure, and we are right now in discussion with the service companies to actually monetize the crude that we have discovered. The H2S percentage is very high, but that's what the challenge is, and we are getting ready to face that. Okay, so to conclude with this, I will take this opportunity to thank the actual well site personals who were there at the well site, who tackled such high percentage of H2S, and our service partner companies, Schlumberger, Halliburton, and the operator partners, Indian Oil and Bharat Petrol Resources Limited, who faced through these operations and successfully mitigated high S2S, coming out with flying colors. The main accomplishment was no lost time injury. We did not have any lost time injury. The only shutdown that we faced in the operation was 24-hour shutdown to replan and recalibrate the operational strategy. Thank you. That's all.
Thanks a lot, Vishwanath, for a very, very in-depth presentation on how you actually manage one of the major accident risks in our whole oil and gas industry. And I'm aware that it is not very easy tackling too many stakeholders, your company stakeholders, the third party, etc.
Right,
So
ma'am.
kudos to you, your
Thank
team.
you. Thanks a lot.
So by this we come towards the end of the session, and I appreciate that all the four speakers brought all different perspectives to the whole theme of the session. And I wish this session was somewhere towards the initial phases of the technical session, because they are very, very good learning opportunities for all of us here. Thanks a lot.